Yo, 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 here we go! Converting to scientific notation. There is another video converting from scientific notation to get a normal number. But we're going the other way here. We're going to start with a normal number and we're going to write it like a scientist in scientific notation. And there are three things to think about here. Number one, find the decimal point. This one doesn't have a decimal point, so if it's not there, it's at the end. Right there. If you have a whole number, no decimal, it's at the end. That's where it secretly is. And then we actually want to place a decimal point after the first significant digit. That's the first digit that is not a zero. So if we read from left to right and have a look, oh, there we go, 4. That's the first significant digit. So the decimal point needs to be right there. That's where we want it to be. So we're going to have to move it. We'll have to think about how far it has to move. To get to this point here, the decimal point has to move to the left 1, 2, 3 places. So this will be 4.96 times 10 to the power of 3. Hey, but Mr. Ranieri, how do you know that it's positive 3 and not negative 3? Well, that is a really good question, and I'm very glad that you asked. Because it's a big number. So this thing has to be positive. Previously, we saw if this thing is positive, the number is big, and if it's negative, the number is small. So yes, it's a big number, so that thing is positive. And it moved 3 places, that's why that's 3. The decimal point was here, 4.96, that's why that's 4.96. Let's do another one, 52. Find the decimal point. If it's not there, it's at the end. So the decimal point is right here. We want it to be after the first significant digit. So we read left to right. Bing! We want it to be after the 5. So it's currently over there and we want it to be there. How far does it need to move? Just one place. 52 is a big number. So when I write my 5.2, because the decimal point has moved here, it's going to be times 10 to the power of positive 1, because it moved one place. When I say big number, by the way, I really just mean bigger than 1. 52 I consider to be a big number. Okay, what about this one? Oh, this is going the other way. This is a very small number. The decimal point's going to start here. That's where it is. And I want it to move after the first significant digit. We read left to right and look for the first digit. It's not a 0. Beep, 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 bing. Good. So we want it to be after that digit, right there. That's where we want the decimal point to be. Okay, well, how far does it need to move to get there? It's going to move to the right. It's going to move 1, 2 places. So now a number will look like 8.2. I mean, yes, it does have all these zeros in front of it, but we wouldn't write those leading zeros, would we? We'd just write 8.2. So any leading zeros at the front, you can get rid of. And now how far did it move? It moved 2 places. So it's times 10 to the power of negative 2. Why negative 2? Well, because 0.082 is a small number. So it's a negative power. One last one to practice. The decimal point starts here. We want it to move after the first significant digit. Let's find the first significant digit together. Ping, 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 ping. There it is, after there. So we want the decimal point to be right there. How far does it have to move? A 1, a 2, a 3, 4. It moves 4 places. I can get rid of all the leading zeros. So I have 9.15 times 10 to the power of minus 4. 4, because it moved 4 places, and negative, because this number was very small. Bada bing, bada boom. And that, my friends, is how you convert to scientific notation. Auf Wiedersehen, au revoir.